So rounding out our discussion of 6.4 and slope, we're now going to take it all the way back. So we're going to go back to the equations of lines and we're going to practice graphing. These ones we're going to use the table method. Oops, I'm still in green. And not the intercept method. And so in these ones, what we're going to do is use the table method. And again, as a little review, that means that you get to choose the values of x, and you're going to solve for the values of y. And so when you take a look at these ones, that idea that you can choose any values you want for x so long as they work out relatively easily. Over here we have good old fraction, which gives the star, right? We have to be careful in our choices. With this one, I'm going to pick little numbers. You could pick negative numbers, and on here we've got 4 blanks in my chart. You only technically need 2 ever to graph, but we were doing that one as backup. So the values of x that I'm going to choose are 0, because I find that one easy to sub in, a 1, a 2, and a 3. So again, like I've been doing this, solving, showing my work, what I'm doing with this is subbing a 0 in where I see the x. And so when x is 0, y is 0, and that's an ordered pair on my equation of the line. And so again, with the next one, what I'm saying is if I sub 1 in for x, I'd have -2 times 1, so y would equal a -2. So -2 would be my next ordered pair, so at 1 and -2. The next one here, subbing in a 2 where I see an x gives me yet another ordered pair, and so this would be y equaling a -4. Oops, that looks like a 9. So graphing that would be a 2 and -4. From this point, you can pretty much see where 3 is going to put you, but you can do the math on it as well. So y equaling -2 times 3, and there's your -6. And so drawing the equation of the line, well, almost hitting the dots, pretend I did, you can see that we do have a slope of a line. It is a negative slope of the line, and go from one dot to another, you'd move down 2 and over 1. We're going to keep counting on those ones. We're going to keep reinforcing the theory behind or the concepts behind these slopes, but this gives us a chance to graph something that is a simple equation of a line. So the next one here, another one to do, again, this time with that caveat that you can choose your numbers carefully. I'm going to pick maybe, I'll go to a negative number, because why not? -3, 0, 3, and 6. And I chose multiples of 3 because I have the 3 in the denominator here. So showing my work, subbing this in, there's a little bit of fraction work. I'd have 1/3 times -3. So that's the same as -3 over 1, or over 3, sorry, which is a -1. And so y would equal a -3 there. Again, you can show your work as you go through. We'd have 1/3 times 0, which is just 0. And with 3 there, we'd have y equaling 1/3 times 3. So that gives me a +1. And then the 6, subbing that in, you might be able to do it without showing your work, but I'm going to. That would give us a 2 there. And so graphing these ones that have -3 and -1, 0 and 0, 3 and 1, and 6 and 2. And that way you can see this line. Oh, I nailed it. That is a good line of this equation graphed. And if we take a look at it, to get from one point on the line to another, we've got a rise of 1 and a run of 3. Have you seen anything about the coefficient on the x term yet? So a bit of a spoiler here, the coefficient on your x term is the slope of the line. And so we're going to come back to that as we move into chapter 7. These ones reinforce that idea of the table method and putting these equations on a line, or on a graph, sorry. And again, we can take a look at that coefficient because it does work out in all of these to be that slope. And remember, this -2 was over 1, so that's down 2 and over 1. The further extension of this is sort of odd, and without a real understanding, you might wonder why this is in there. So these are graphs or direct variation. So those two examples that I just had are direct variation. A common example is an hourly rate. So you're going to make a profit of your hourly rate times the hours that you work, right? And so in this one, what we've got is a constant of variation. And so because constant, I'm sure in somebody's land starts with a K, I don't know if it's another language or what, we use a K here as the coefficient on our X term. And the reason why this section on direct variation is in here is because they are linear equations, and this constant of variation is the slope of our graph. And that's really, written between the lines. But that's why I'm here, is to give you that idea of context and why this is here. So let's take a look at this one. So Marina earns $9 an hour as a tutor. And so write an equation that describes the relationship between the hours she works and her pay. So her pay would equal 9 times the hours that she worked. And so in here, P, is her pay. And you could use an H or whatever. I use an X for the hours worked. And it's starting with one that's intuitive. You totally know how to do that stuff. Where I'm going with this is saying, hey, this is a linear equation. The 9, the rate of pay, is our constant of variation. And anything that is a direct relationship fits this format, this generalized format, that y equals some constant times the x. And so this is a general kind of framework equation that's at the top of the page there for anything that you see is directly related to or directly proportional to. So another one here. Serena's driving at a constant rate of 50 kilometers an hour. Write an equation that shows the distance she travels an hour. So we know that distance equals rate times time. And in this one, we don't necessarily know her distance. We don't necessarily know her times, but it would fit the linear equation that distance equals 50 times the time that she travels. And so that would be the equation that shows the distance she travels in hours. And again, it fits this y equaling kx as a generalized equation in math with direct variation. So taking it away from these kind of applications and things that probably make sense to you, back into the world of math, the next questions say that y varies directly with x, which is your cue that it fits this format of equation. So we know here that when y is 30 and x is 6, we know that this is true. And so it says find the proportionality constant. It says solve for k. That's what we're looking for. And so what we can do is start with our kind of standard form, that framework equation, and sub in what we know. So we'd have 30 for the y, we'd have k that we're looking for, and we'd have 6 for the x. And so what we're doing here is solving for k. To get k by itself, we divide both sides by 6, and I'd know that k equals a 5. So the equation for this would be that y equals 5 times x. So this is the proportionality constant. This is the equation that is the linear equation that's being talked about here with this proportionality constant. Another one, again, the fact is given to you that y varies directly with x. As soon as you see that language, that means that it's going to fit this format. And here it says that y equals 100 and x equals 25. And so what we're going to do with that is sub in what we know. Again, this is our framework equation. So we've got y equaling kx, and we're looking for k. So we're solving for k. We'd have 100 equaling k times 25, and solving for k, we'd get that k equals 4. So finding the equation, giving the equation, taking it one step further. I know the question doesn't say this. Y would equal 4 times x. And this is a generalized equation that is being talked about in this example. So that rounds out our discussion. Oops, sorry, there were two more. Okay, hang on. One more. So it says y varies directly with x, and we have a constant of variation of -1/3. So in this one, we need to come up with that framework equation. So the framework equation would be y equaling kx, and this time we know k. So the actual equation that we're dealing with is y equaling a -1/3 x. That is the equation of the line. It says start with a table to find 2 points, plot them on the graph, and draw a line. So you can do more than 2 points. I'm just going to do 2 because I'm feeling lazy and I already thought we were done the notes for this section. So again, I've got fractions as my coefficient of x, and I'm going to pick 0 and 3. So I don't want to deal with fractions. So subbing that in, I'd have -1/3 times 0, and solving for my y, oops, sorry, doesn't equal y, it equals 0. Doing the other one, y equaling a -1/3 times 3, I'd have that y equals a -1. So now I have the 2 points to put on the graph, and I can try, not very well, to draw a straight line on the graph. When we had the coefficient of x before, I said it was the slope. So check this out. This one says that the slope is down 1 and over 3. So to go from one point to another, that's what I should be able to find. So from this point, I go down 1 and over 3. And in that way, again, the coefficient on the x term, whether you call it slope or whether you call it the constant of variation, is the slope for the line that the equation is making. So one last one here. And again, we're going to use the table method to put this on the graph. So we've got that y equaling, because it says let y vary directly with x, so 2/5 x. That gives me my equation that I'm dealing with. And again, it's that framework equation of direct variation. And I could make a chart. In this case, because I have this fractional coefficient, I want to pick multiples of 5. Well, I'm going to be lazy and pick 0 and 5. Subbing that in, I'd have y equaling 2/5, times 0, or 0 and 0 is a point on my line. And subbing in the 5, I'd have y equaling 2/5 times 5, which is y equaling 2. So I'd have another point here at 5 and 2. If I were to carefully, almost did it, draw the line on the graph, what this is telling me that my slope is that coefficient on x, right? And it's telling me to go from one point to another, I'd go up 2 and over 5. I have a rise of 2 and a run of 5. So that does complete the section on slope and chapter 6. You do have a number of text questions assigned. If you need more graph paper, ask, or you can do sketchy graphs like I've illustrated to you. I'm sure your lines and your graphs will be neater. I don't have a ruler for the notes in making mine. And also on the back side of your homework is a fun activity to do with a riddle. So yeah, you can look forward to a really, really cheesy bad joke. It's very punny though. Anyway, thanks for chapter 6.